Today's lesson is 5-2 proportional and non-proportional relationships. So in this lesson, you are going to be working on identifying whether a set of numbers in a given situation, real life world situation, whether those numbers are creating a proportional relationship or something that's called a non-proportional relationship. So if you have a proportional relationship, the two quantities are proportional if they have a constant ratio. Oops, look at how bad I can't write today. Oh, look at it, straightened it out for me. Um, or an equal unit rate. And they didn't put that up there. So we're going to write that in because I think that that's important. Oops, what am I doing here? There we go. So this really should say, or an equal unit rate, okay? If you have a relationship that's non-proportional, a non-proportional relationship is a relationship in which the ratio is not constant or does not have an equal unit rate, okay? So if it has an equal unit rate or it's a constant rate, then it's proportional. If it does not, then it is not, okay? So for this lesson today, you're going to be, and this is huge, you would misspelled that word, you are going to be required to solve all problems showing a ratio table. So you are going to have to create a ratio table for every single problem. Your ratio table oops, must consist of at least 3 values. Okay? Has to have at least 3 numbers in it. Not 2, not 1, 3. Okay? There are lots of ways to determine proportionality. So if I'm ordering pizzas here and the cost of the order over the pizzas ordered, so if my cost of my order is $8 for every 1 pizza, okay, that's my cost, okay. I want to know if that is a proportional relationship or not a proportional relationship. So if I would create my ratio table, and you need to label it, this would be the cost, and this would be the pizzas, okay? And you have to have at least 3 values, and it tells you that it's $8 for every 1 pizza. So if I buy 2 pizzas, it's 16, and if I buy 3 pizzas, it's 24. Now, to determine if that's, and some of you are going to look at it and say it is, and somebody going to look at it and say, oh, nope, I don't think it is. You have to show me because I need to see your thinking. So there's 2 ways you can go about solving these types of problems, and I'm going to show right now both of them, and then later for the sample problems, the example problems, I'll do one way and one the other. So in this situation, I'm going to do, I think I'm going to do I'm going to do unit rate. So if I calculate a unit rate, that would mean that it's dollars per pizza. So this is going to have a unit rate of 8. This is going to have a unit rate of 8. And this is going to have a unit rate of 8. As long as your unit rates are all the same, then it's a constant unit rate. And if it has a constant unit rate, it's a proportional relationship. The other way that you could do it is what we did yesterday in class, where you are looking at um, a, whether it's constant or not. And you can do that through an additive or multiplicative relationship. I suggest that you do multiplicative because it's going to be easier if you do multiplicative, especially for what we're going to do later. So if I have 8 to 16, what did I do to get there? I multiplied it by 2. Well, if I multiply that by 2, I have to multiply this by 2. And did I do that? Yes, I did. Okay, then I go from 8 to 24. What did I do to get that? I multiplied by 3. So if I go from 1 to 3, I also have to multiply by 3. Because that works out, it's equivalent fractions. or in this case it's equivalent ratios, because they are equivalent ratios, they would they would have a equal unit rate and therefore would have a constant rate. So you are going to have to show either that times 2 times 3, etc., or you're going to have to show what the unit rate is down here. And really, my personal opinion is right now, based on where we are, calculating this unit rate is going to be the easiest way to go about it. Okay? And then you're going to have to explain it in words. All right, in terms of what you did. Okay? So let's look at example number 1. So this is, I just talked or just did this or showed you this. There's 2 ways to determine proportionality. Okay? You can use one of 2 methods. All right? You can determine whether it has an equal unit rate, or you can determine whether it has a constant rate. If it changes at a constant rate. Either one of those is fine. But you need to make sure that no matter which one you pick, that you explain if it's proportional or non-proportional, I keep hitting that, and why. Is it proportional or non-proportional, and why? Okay, so this first example talks about Andrew, who earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing lawns? So for this problem, I'm going to do a constant rate. Okay, so he has $18, $18 for 1 hour. Okay, so what did I do to 18 to get it to be 36? I multiplied it by 2. So what do I do to 1? I multiply it by 2. Okay, now what did I do to 18 to get it to be 54? I multiplied it by 3. Did I multiply 1 times 3 to get 3? Yes, I did. Then if I did, I want to do a different color, if I 18 to 72 and 1 to 4, you multiply those by 4. So therefore, we are increasing at a constant rate, right? So you would say that, and this is the work I want to see, create your ratio table, plunk in at least 3 values, and then show me those steps. And then you have to say to yourself, okay, is this proportional or is it non-proportional? So you would say that, and you go back to the context of the problems. And I am going to, I think, because it's too difficult for me to do that, I think I'm going to type it because I can type faster than I can. Okay, so you would say that the amount of money that Andrew earns is proportional. I think I'm going to the number of hours worked, because, and then this is where you have to look at what you did. What did I do? This is showing it has a constant rate because they increase at a constant rate. Okay, that would be your sentence. All right. Okay, if you don't understand that, you should rewatch. I want you now to do letter A. So you are going to pause your computer and I want you to create a ratio table, calculate something, whether it's going to be the unit rates or a constant rate. This is constant rate. And then explain it in words based on the context, back to the context of the problem. And then when you're done, come back. Okay, so this is at Lakeview Middle School. There are 2 homeroom teachers assigned to every 48 students. So I need to create a ratio table. So when I create a ratio table, this is my ratio table. This is, how did I do this? This is teachers. And this is students. And you can abbreviate. Okay, you have to have at least 3. Now, they don't give you a unit rate in this problem. They start you out with 2 teachers, so I'm going to put that right here for 48 students. Now, I'm doing that because I want this number right here to be my unit rate. How many teachers per student? Students per teacher. So this would be 1, and then this we have to figure out. And then over here, I'm just going to go 3. And you should just pick easy numbers. Don't get hard numbers. Don't make it any harder than it needs to be. Okay, so I have to figure out if this is going to be at a constant rate. So if 2 and 48, what would this be? This is going to be half of that, right? What did I do to 2 to get it to be 1? I divided it by 2, so 48 divided by 2 is 24. And then what did I do to get this number? If it's 1 is 24, 2 is 48, what is 3 going to be? 3 is going to be 72. And I think just for good measure, I'm going to add 4 on here too. And 4 would be 96. Okay, now for this problem, I'm going to calculate unit rates. So right here, we did a unit rate. So the unit rate here is 24 students per teacher. The unit rate here, 48 divided by 2 is 24. The unit rate here, 72 divided by 3 is 24. And the unit rate here, 96 divided by 4 is 24. So to do this, I did 24 divided by 1, 48 divided by 2, etc. Okay. Now, you have to tell me, is this proportional or not? Is the number of students to the number of teachers proportional at Lakeview Middle School? And you would have to write your answer. So we're going to do that. And you would say the number of teachers per, I think I'm going to do it the other way, the number of students, because I think you'd more than likely say students per teacher, although it really doesn't matter in this situation. Some of them do matter if it's the common ones, but this doesn't really matter. So the number of students per teacher is proportional because they have an equal unit rate. Oops, I gotta go on to the next page. Jeez, Mrs. Shaw can't type. Oh, what is wrong here? Okay, so that would be your sentence. All right. Okay. So if you don't understand that or you got that wrong, you need to go back and rewatch. If not, you can move on. Okay, number 2. Example 2 that they have in your book. And I'm going to kind of cruise through 2, 3, and then I'll spend a little bit more time on 4. For number 2, again, you're doing all of these, you're doing exactly the same thing. You either have a ratio table that's given to you or you have to create a ratio table. When a ratio table is given to you, and in my opinion, it's easier to do, way easier to figure out, oh, excuse me, it's way easier to figure out the answer based on unit rate, doing an equivalent unit rate. When you're not given a ratio table, then sometimes it's easier to do it as equivalent or constant rate, increasing by a constant rate. Okay, so I have 10 to 1. So if I'm going to calculate my unit rate, it's dollars per ticket. So 10 to 1 is $10, right? That's a unit rate of 10. 17 to 2, so you take 17 and you divide it by 2. And if I take 17 and I divide it by 2, I'm going to end up with an answer of 8.5. And then 24 divided by 3 I'm going to end up with an answer of 8. And 31 divided by 4, I'm going to end up with an answer of 7.75. Okay, so what's happening here is the more tickets you buy, the less money you have to pay. But because they're giving you that price break, is this proportional? And you would say, no, it's not proportional. This is not a proportional relationship. I would say, and I would use what they have here, the ticket charge for the baseball game is not proportional because it does not have an equivalent unit rate. Okay, because it doesn't have an equivalent unit rate. All right, let's look at number 3. Number 3 is really doing the same exact thing, except that this time you have a fraction there. So you can do the same thing when you solve it. You can do either equivalent ratios, constant rate, increasing at a constant rate, or you can do unit rate. Either one would be fine. You just have to then say, is this proportional or not? And if you figured this out, they divided here and calculated right here underneath your unit rate. It's 0.5, 0.5, 0.5, and 0.5, which means that it is a proportional relationship. Okay, so I would like you to pause your computer and I would like you to do problem B and then come back. Okay, at the beginning of the year, Isabel had $120 in the bank. Each week she deposited another $20. Is the account balance proportional to the number of weeks in deposits? Use the table below and explain your reasoning. Okay, because of the way this starts, it says that she starts out with $120. So I like to add this, and I'm going to put it right in front because I like to go in numerical order. 0 weeks, she has $120, right? Because that's what she started with without any of the weeks. Then she's depositing 20. So her first week she deposits 20, so this is 140. Her second week she deposits another 20, so this is 160. And her third week she deposits another 20, so this is 180. Okay? Now, you can calculate your constant rates, or you can do I can't think. You can do you can do unit rate. Okay, so if I do a unit rate, I have 1 week, and that's 140, so it's $140 per week, right? This is 160 divided by 2, that's going to be 80. And this is 180 divided by 3, that is going to be, what is that going to be? 60, right? So do these have equal unit rates? They do not. Because they don't have an equivalent unit rate, they are non-proportional. The other way that you could do it, again, would be to do a constant rate. From 1 to 2, I multiplied by 2. So did I multiply 140 by 2 to get 160? No, that doesn't work out. And then I would double check and do the next one, 1 to 3. What did I do? I multiplied by 3. So do 140 times 3, just to see if you made a calculation error. And again, you could say that this is also non-proportional because it does not have an equivalent unit rate, or it does not increase at a constant rate. Okay, number 4. Number 4 says the tables shown represent the number of pages Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? So again, you have to do the same thing we've been doing, except that now you're going to compare two. So you have to solve both, and then you have to tell me which one is proportional or not. And if you did this, you would find out that Martin's unit rate every single time is 0.4, 0.4, and 0.4. And Gabriel's unit rate is 0.6, then 0.4, then 0.46, repeating. So which one has a proportional relationship? Martin reads at a proportional relationship in terms of his time and pages read. His is a proportional relationship because why? And how did I do it? Because if they don't, he has an equal unit rate where Gabe does not. So that's really how you do those types of problems. Okay, so you have a worksheet that you're going to complete, and you need to do problems 1 and 2, making sure that you complete your ratio tables up here for 1. and then show me either the constant rate or unit rate, and then explain it in words. And the same thing for number 2. Show me the unit rate or the constant rate for both of them, and then tell me which one's proportional and why. Okay? Now I do want to talk a little bit about something that is from the last, it's a whole section in my previous book, and it's something that you do need to be somewhat aware of, and this is called dimensional analysis. All dimensional analysis is the converting of rates, okay? And you have to compute those rates based on your calculations of converting standard or metric measurement. Okay, so when you're doing this, it says the process of including, and this is an example of dimensional analysis. You don't have to do it as dimensional analysis, but I did want to show you a dimensional analysis problem so that you get an idea of what you're doing. Because this is something that you are going to be expected to do in the future, and setting it up the proper way. So this is an example of dimensional analysis. It says a remote control car travels at a rate of 10 feet per second. So when I do problems like this, I like to start by writing, and I'm going to do my own, even though they did it. I like to start by writing what you have. So it's 10 feet per 1 second. And then what I like to do is I like to figure out where they want me to go. And they want me to go to inches per second. So my label at the end, in the end game, has to be inches per second. Okay? Now, to do that, you're going to convert. So I need to change what? I need to change seconds? No, because it stays second to second. So I'm not going to do anything with my seconds. But I need to change this feet. So you're going to multiply by a conversion fraction, a conversion ratio actually is what it is. So I want to turn feet into inches. So you have to, this is what we talked about yesterday about the cross-simplifying of labels. So I need to get rid of this feet, so feet's got to go on the bottom because I'm going to simplify it out. And inches then goes on the top because this is my conversion ratio. How many inches are in 1 foot? And it's 12. Okay? That then allows you to get your answer because you can cross out the labels feet and feet, right? And you're left with the labels of seconds and inches, which is what we want. And to solve it then, you just multiply the numbers. 10 times 12 is 120, and 1 times 1 is 1. Now, this is dimensional analysis. Writing conversion ratios, that's huge because you're going to have to be able to do this later on in high school and 8th grade and high school. So I just thought I would show you the way that we're going to do it. I'm not going to expect you to set it up this way, but you can if you want. Okay? So I want you, I don't know which one am I going to have you do. I can't remember which one I wanted you to do. I would like you to do, let's do, let's do, A. Okay? A. So pause your computer and try to come up with a way that you can calculate or figure out how you're going to convert A, and then come back. Okay, so it says a gull can fly at a speed of 22 miles per hour. So the first thing you do is you start by writing down your rate. 22 miles in 1 hour. Ooh, what if you just do, what the heck? Wow, that is weird. I've never seen that before. Okay. In 1 hour. Okay. So I need to turn this, and I like to put, like I said before, my label at the end. So I want to turn this into feet per hour. So my miles has to become feet. And it's 1 hour. Okay. I don't do anything then with my hour. So how do I turn 22 miles into feet? You need to know the conversion for how many feet are in a mile. So you're going to, and that 5,280 is the answer. So you're going to take 22 and you're going to multiply that times 5,280. because there's 5,280 feet in 1 mile. And you could do this like dimensional analysis in 1 mile. Okay, then you have, and you don't have to show this conversion, but you do have to know how you're going to do it. So you take 22 and you're going to multiply that times 5,280 and you're going to get an answer of 116, comma, 160, and that is feet, oh my goodness, I can't remember this, per hour. Okay, feet per hour. I just wanted to show you that you are going to have to do a word problem like this, and whether you choose to set it up with dimensional analysis and realize, oh, hey, look, I can cross out these labels of miles and miles and I'm left with feet and hours, that's up to you. I'm not going to make you do the dimensional analysis, but you are going to have to figure out how to convert these numbers using your conversions. That's in your agenda. I'm going to give you card stock of the conversion, so you'll have all of these things if it's necessary or for you to use. But they are in your agenda as well. Okay, I am done. This is a fairly long video, I think.